Hi, this is Developers here. My name is Melody Leonard, and in this tutorial series, we'll be looking at the Solidity environment, how we can write smart contracts and deploy our code to the blockchain. Um, in this tutorial, we'll be looking at writing a smart contract that allows the owner of an account to mint a token or a coin, and that coin can be sent to any account. But before we do that, we want to look at the Remix IDE and try to understand what is actually going on here. So this is your file explorer in your Remix, and you see that here you can create a folder, you can create a new file, you can connect with GitHub and push your code there, or you can load a file from your local storage and stuff like that. And here we have the contracts. This is basically where you want to write your smart contract code. This is your where your deployment scripts. So you can write a script that deploys your code, and stuff like that. You have your tests, right? You can write tests in Solidity or blockchain. We test a lot. We write tons and tons of tests. So we want to make sure that every case is working the way it should. Because when you push your code to the blockchain, it doesn't change. You can only deploy another instance of your code, but that particular code cannot be altered. So you want to make sure that you're testing that things are working the way they do and the way you want them to work, right? So we have all these connected, and we have the some contrast we've written probably in the past, right? So here we have our compiler, right? This everything that has to do with our compiler. You can see here the compiler version we're using. We can choose a different one if we want. The language we want to use to write. Here we are choosing Solidity. You can use your, which is another option, and basically any other language of your choice if it's available, right? And you have an EVM, which is the Ethereum virtual machine version you're using. We are currently using the default, all right? And we this is a compile button, right? Just say you write your smart contract you want to compile, you can use the compile and it will compile your code for you, right? And here we have this is our deployment and running our code. This allows us to run or deploy our code. Here you can see that we are using an environment. And the environment we are currently on is the JavaScript virtual machine. And what this is like, it simulates the blockchain environment. So it's a JavaScript virtual machine that kind of simulates the blockchain, right? It allows you to run your code and make it possible, so it's going to be way faster than connecting your code to the blockchain and having to wait all along to deploy your code to, send something and all those gas fees, stuff like that. This just provides you with, a test environment where you could just do this and run your code as soon as possible. And of course, whatever you learn with this JavaScript virtual machine is fully attributed to the real world. So you don't have to bother about going to get a new idea or a new knowledge of the actual blockchain environment. And these are accounts, right? So these are all fake accounts, or accounts that are present, and all these have 100 ether. So you can test with these accounts, right? So we equally have a gas limits, and this, we actually explained what a gas limit is. I would suggest you go back to the previous video and watch what we actually explained there. So these are basically your way, which is basically you know the smaller fraction of the Ethereum. And here you have your plugins. So currently we have one plugin, Solidity Compiler. You can add different plugins you want to use to enable you write better code and faster code. So let's go ahead and create a contract called coin, right? Remember, Solidity files end with .sol, so you want to do that. Now we can go ahead and define the compiler version we want to use. But when we try to compile our code, it's going to give us an error. And this is because in the earlier version of Solidity, right, you have to specify that you want to actually use a license, right? So you have to include this thing here, this line of code that looks like a commented out code. You have to actually include it to tell the your compiler what license you are using, right? So having done that, we specify the compiler, the Solidity compiler we want to use. The way you do that is using the word or the keyword pragma. Say pragma solidity, and you specify the compiler version you want to use. Now, because we want to cause some error or want to handle some error, and the error was actually introduced in an earlier version of Solidity about 8.0.4 or 8.08 0.8.0 or thereabout. So we want to make sure that we are using something within this range or is above this range. So we're going to go ahead and do that, right? So let's leave this at 4. And we can start writing our smart contract code. So we want to call our contract. Remember, all your smart contract code start with the keyword contract, right? So you want to say contract. And what would you call this code? Well, we're going to call it coin. Happiness, right? Yeah. Now, let's think of how we are going to handle this. Now, there are going to be lots of accounts on our smart contracts, right? And all these accounts, of course, the owner of the account is going to be equally present, right? So we want to allow the owner to mint the coin. Now, the owner can send this coin to just any account, right? And whosoever has this coin can equally send it to any account. So there are going to be lists of accounts, right? And the way we want to do this is we want to make sure that we have a situation, something like this. We have something like this where we can have an account one. This is just an example, guys. So let's visualize what we are looking at, right? We can have an account one to have about $40. We can have an account two, right, to have about $80, and just so on and so forth. So all these are going to be lists of accounts, right? And the way you replicate this in Solidity is use something called map, right? You're going to use something called map. So map is just basically key value pairs, and key value pairs are basically what you just saw here. These are keys and these are values, right? So let's use the keyword map, right? And when we want to map this, right, in our map operation or map keyword, you can say mapping, right? We want a situation whereby the key is going to be an account, just as we have here. So we are going to have, say the address. Now, this remember the Solidity is a typed language, right? So we are specifying that whatever the account is going to be an address. An address is basically like saying that this is going to be an account. So when you go here, uh, this is an account, right? This is like an address, like this is an account address, right? So and Solidity allows you this type. There's this type called address, and that can be used to store account addresses, right? You can use it to store other things, but it's best to store account addresses, right? So you say this is going to be an address, and this address the value of the address is going to be an integer, which is a number, right? So let's say an unsigned integer, a uint. Sorry, why am I saying units? This is so crazy. Uint, and uint, let's see, 256. So we are going to say that this is an address that has an integer. So the amount or amount of money or coin the person has is going to be specified with uint. I want to name this, right? So whatever this is, let's call it balances, right? So each sorry, so each address is going to have this is just the balances of each account in our app, right? But we want to make this public. Now by specifying this to be public, you're doing two things in the remit, right? You're doing one thing actually in the remit. You're actually allowing remits to create a default getter for you. So remit is going to create a default getter for you that allows you to get or query these balances, right? Or balance, and it's equally going to allow you to call or have these balances visible to other contracts, right? So we can have different contracts in the in an app, right? And when you say something is public, other contracts can actually access that value. So we want to leave it as public. Now we want to go ahead and create a function that allows you to mint, or that allows just the owner to mint a coin. Now let's create a function. The way you do that is called the keyword function. And you say this function, well, what we are going, what are you name the function, right? What we are going to call this function is basically mint, or mint, mint token or mint coin, right? And now we want to mint this coin. When this coin is being mint, or is mint, right? We want to save the coin to an account, of course, right? Remember, we don't need this. This is just an example, right? But we want to save this coin to an account. Now, we are going to save that, of course, in an address, right? And that address is going to be, of course, the receiver. So what we are basically doing here is Solidity is a types language. So when you want to write something like, when you want to say or call something like this, you want to say a person or name, you have to tell Solidity what name it's going to be. You're going to tell Solidity that, okay, this name is going to be a strange, or it's going to be a number or whatever. If you don't tell Solidity, you're going to have a compilation error. It's not going to compile your code successfully. So this way, it allows you, it makes sure that a different type is not being referenced to another type. So we're saying that a receiver, whosoever is receiving this coin we are trying to mint, is going to be an address, right? I want to equally say that, well, not just the receiver, we're actually going to pass an amount. Well, how much are you going to be giving, or how much of a coin are we going to be minting? Well, that is going to be specified with amount. Amount, and remember, this amount is actually a uint, so we specify that it's actually a uint of 256. And I always do this, I always say units, right? And we go ahead and open a function. Okay, now remember, we want to make this function public, well, so it can be accessed, right? So we say this function is equally public. Now, what are we going to do here? We remember we have our key value pairs, something like this, right? And these are list of accounts, right? What we want to do is, let me explain this from the JavaScript word, and I hope we actually understand. So these are uh, balances, right? So you can call something like this. You can say balances, and you pass in the account one. And what this is going to do is it's going to return whatever is, or whatever the value of account one is. So here it's going to return 40. Right? If you say balances and pass in account two, it's going to return uh it's going to return 80, right? It's going to return 80. And this is actually called mapping in JavaScript. I don't know what it's called in other places, but this is actually called mapping in JavaScript. So you're saying that, okay, whatever this is, right? This, okay, in the case here, we are going to use balances, right? I just want to go through and get whatever matches the key. Well, I'm passing a key, and whatever matches that key, just return it for me. This is something as saying, if this is not a strange, right? Let's say this is actually, we are having something like this name. Let's say account one, and we are saying something like account two. This is something like saying balances dot account one, and it's going to return 40, right? But here is a strange. We are actually going to use this, you know, this is that called? This is called brackets, right? So we are going to use this brackets, and it's going to do the same thing as in this case here for us. So having understood that, let's go ahead and do that. So we want to say, well, we want to have our balances, and whosoever the receiver is, right? Want to find the receiver, whatever that is, right? We are going to pass a receiver. Remember, when trying to mint the token, we are going to pass a receiver. And when we are trying to do that, when we do that, we are going to get the number of amount of that person's token. Whatever is there currently is going to be zero, right? We're all going to have, or different accounts are going to have zero uh, token, right? So when we pass the receiver, I want to say whatever their token is, add it to the amount or the amount of token. You can call it amount token or token amount or whatever. So add it to the amount and let it be the new value in their account. So what this means is this: it means that when we do this, right, it's going to have 40. So when we have amount, let's say we pass an amount of 30, it's going to add 40 to 30. And the new amount we're going to have is going to be 70. And we'll have that. What do we do, guys? We put our semicolon. So with this, we have just handled the minting of token. And right now, guys, we can go ahead and run this code. Let's go ahead and compile it. So go to our compile, right? And try to compile this code. And you see it compiles successfully. We can actually go ahead and deploy this code. And you're going to see the function mint token. So let's go ahead and deploy it. Go ahead, go here, deploy, right? We're having a gas limit of this. So it means that, okay, this is the this is the highest amount we are willing to spend on gas. So if I deploy this, we're going to see that it deploys it for us. There's a successful message here. Let me take this up a bit. Oh, I hate doing this, guys. I just hate, like, this is so, I have to be very precise to do this. You can see a successful message here. Set is transaction mined and executed success. And you can see the the hash. You can see the account here, right? This is referencing this, right? This is from this person, and it's going to the constructor, right? And stuff like that, and just basically some messages. And you see this here. So if I go ahead and open this, right? Let's go ahead and click this transaction here. Okay, yeah, we can't do this yet because we've not written a getter, right? So this is a transaction here executed successfully. Well, I'm going to go ahead and delete this because, well, I don't need this. I just wanted to show you that you can deploy this code and run it. So let's go ahead and delete it. And you see that we currently do not have any transaction. Well, we've done this now. We want to go ahead and write, a function that allows us to send the token to whosoever. But before that, remember we said we want a situation whereby just the owner of the account can actually mint tokens, right? Just the owner of the account can actually mint a token. So the way you do that is actually say use the required keyword, right? So we are going to create a constructor. The constructor is going to be the first code that runs when the code comes live. And this is actually something that is introduced in the earlier version of Solidity. Uh, sorry, the later version of Solidity. Earlier, in the earlier version, you can actually use the keyword function to create a constructor for yourself. So I'm going to say constructor, and I'm going to say that, well, I want the owner. I'm going to have a keyword or a variable called owner, and that owner should be equals the message dot sender. And this message dot sender is actually a global variable, so it's just available for you in the Solidity, right? And this message has some bunch of things there for you. It has a sender, it has some other values, right? So I'm going to say whosoever is sending or publishing this contract should be the owner. Well, remember we've actually said, okay, this is the owner, right? But this owner is not being defined. We have not defined this owner. Like, where is this? Like, is this owner an integer? Is it a number? Is it a string? Is it a struct or whatever? We do not know yet. So we are going to say, well, this owner, right, is going to be an address. Of course, it's an account, right? So we say address owner, and this works for us. So we can go ahead and put public, right? If we want public, so it's going to be visible to other contracts, or we can just leave it this way. Now we have this, right? We say, okay, an address is an address, and that address is going to be the owner, and whosoever is sending this should be the owner. So that first person is going to be the owner. And this way, we can now put something called a require, right? You can say a require. Require means actually, before you run whatever is below, just do this for me first, right? So we can say require, well, the message dot sender, that's whosoever is trying to perform this action here, this minting of coin should be equals to or equals to the owner. And if this is true, it's going to go ahead and run this. So this is going to return either true or it's going to return false, right? So if this is true, it's going to go ahead and run this. It's going to assign this and do whatever. If it's not going to run it. And when it's not, when this is false, we want to actually tell the user, okay, this is what is actually happening. So you can pass a second argument to the function, to the require function, uh, which actually sends a message back to the user. So we can say you are not permitted to mint a coin, and that works for us, right? So we have this. We are actually making sure that only the owner can, uh, you know, perform this action. So we can go ahead and write a function that allows us to send this, you know, coin we've minted. So currently, if we do this, this coin is actually going to be just for us, right? So we can go ahead and now send this, you know, coin to whosoever we want to, send it to. So we can go ahead and try this, try to compile and see if we have an error. And we do, yes, on line 10. And it says here we need a semicolon. Why didn't I see that? And we need a semicolon here as well. Why didn't I see that? All right, so that solves our problem, right? So let's go ahead and before we push this to the or publish this, right? Let's go ahead and you know what? Let's go ahead and make this reusable, right? So let's create a different contract. Now we are going to do something called inheritance. So we are going to create a contract that allows us to define the owner, right? And this contract here, this other contract here, is going to inherit from that contract. So we can have every attribute that contract has, right? Then we can call this. So wherever we want to make sure that only the owner can perform an operation, we don't have to go ahead and start writing this, you know, this same logic and making sure that okay, we are going to start writing require and all those stuff. We can just call an inherited function, and that is going to work for us, right? So let's call a function or let's create a contract called its own, and we'll move this portion of the code, everything that has to do with the owner, to be its own, right? And we are going to go ahead and create something called a modifier. So a modifier is basically, uh, it's modifiers are like native words, right, to the Solidity, and what it does is it kind of allows you to, you you can pass a modifier to a function, and it's going to modify the state of that function in the sense that okay, it's going that function is going to be it's going to run that modifier, and if that modifier or check passes, then you know the code can run. Otherwise, it's going to just do whatever the modifier states. So let me go ahead and explain this for us. So we have a modifier, right? And we're going to call it this modifier is going to be only the owner, only uh, only the no let's say only owner, right? So only owner should be able to perform this action. And what do we do here? We just copy this require, cut it, and paste it here. So we are going to say that, well, this modifier should try to do this. And if that works, well, go ahead and run the code. Otherwise, uh, just do nothing for us. Or skip the whole process for us. So we can go ahead and inherit from this is owned, right? So we say the its own. This is going to be is and is owned. Or you know what? Let's rename this to owned. So by using the is keyword, we can inherit from you know another contract. So if you say is owned, it's going to inherit from this contract. And now we can now use this only owner, right, in any function down here because this now has everything this one has. So I can now call this here and say this should be done when it's only the owner. And we'll make sure that, and this will now make sure that only the owner can mint a coin in our smart contracts. All right, so I hope that explains it. If you don't understand that, then I would suggest you pause this video, try to wrap your head around it. If I'm going too fast, you can always pause it and try to wrap your head around it. Look at the Solidity documentation so you actually get the full understanding and you get more detail on what we're trying to do here. But what we're trying to do here is basically trying to, you know, we are creating a modifier, and that modifier is like passed to this function. And before we start running our code, the modifier is going to run a check, a validation here. This check is going to make sure that the message the sender is actually equals to the owner, and the owner, we've seen that the owner is going to be the first person that's that runs this contract, or this particular the first code. And the first code is going to be run by who is pushing it, because of course this is being run by once the code initializes or the project initializes. And you can see that here we have that this is coming from this account. So this is the first time we run this code, it's going to say, okay, this is the from, right? And this is going to be the sender. This who is sending it, right? So the message of sender is going to be this account here. And we are saying that that message of sender is going to be this owner here. And we create a modifier that does magic for us. So let's go ahead and create. Uh, let's go ahead and create send. Let's go ahead and make sure that we can send a token or the coin. The coin we just minted, right? Let's go ahead and make sure we can send it to just any other account in the list of accounts we have. So we'll call a function. Let's call it send a coin. Now, of course, we want to send this coin to an address, right? Or a receiver. Someone is going to receive it. So we say, okay, we are sending this coin. The first argument we are going to pass in is the receiver. And this receiver is of course an address. And of course the amount we want to send, which is a uint 256 amount. And want to define this to be public, right? And also, guys, there's something called a payable. So when you define something to be payable, it allows you to send and receive ether, right? So you can send ether to different accounts. When you don't define a function to be payable, it cannot be you can't send ether to that account. So if you want to send ether to a user, right? If you want this user to be able to receive Ethereum, you have to define it to be payable, right? So we are going to define this to be payable for the now, right? And open this. So now we want to run a logic. So what we are going to basically do is, of course, we want to check that, well, the amount the person is sending is, well, whatever they're trying to send and the amount they have already, right? Inside. Now, of course, there's going to be a list of amounts, just the coin. So if I mint a token, let's say I mint 200, there's going to be 200 for me. I can't send 300, right? So we are going to say if now the amount, that's this, whatever I'm trying to send, is greater than the balance. That's what is inside my account. That's balances. I get my the same way, the same thing we did here. Balances dot you know dot sender, right? So balances. Now it's not the receiver here, it's the sender. So how do we get the sender? We do that by saying uh, message dot sender, right? MSG dot sender. Let me explain this now. Remember we said here you can actually map through the key value pairs by doing this. Now we want to make sure that okay, if I'm sending an amount, right? I want the whatever I'm trying to send is not less than what is in my account. And of course, the message dot sender gets my address, right? That's my account, and it's going to allow us to map through the balances we have, and it's going to return whatever balance I have. So if the amount I'm trying to send is greater than what I have already, I don't want to send it. And how do we do this? So when that happens, what we are going to do is we want to revert the we want to revert the you and say the revert, want to revert the transaction. Now, I want to revert this transaction with an error. So I'm going to instantiate an error here. So I'm going to say error. And this error is kind of something more of a new in the Solidity, right? You can check, you can look at the docs and try to read more about it. So you can do error and call it a name, right? So you give a name to it. I'm going to call this sufficient balance, right? And our error is going to so now when we want to revert this, we are going to see how much am I trying to send, right? We want to revert it with how much I'm trying to send, and we want to equally throw to the user what is currently available. So the error is going to have uh, let's say the amount requested, right? Requested amount, and it's going to equally have the available amount. Now, requested amount is actually a number, so you make sure you use your uint, which is unsigned integer, 256, right? And equally, the available amount is going to be an integer, so we use our uint 256, right? So when we use revert, we can say we want to revert with error, revert this with error, so revert insufficient balance, and you know what? Go ahead and tell me the throw back to the user the requested amount, which is the amount they are trying to send, which is this amount here. So we put it here. And the available amount, that's what they have already. And that is going to be this, right? That is going to be this. So what they have already, which is going to map through the balances and with the particular person who is trying to perform this action. So we can say this available here. Well, let's call it available amount. Let's call this requested amount. This will stay more descriptive and available amount. Available amount, and it's going to be this, right? So if this happens, then reverts the whole thing. Otherwise, if it's not, if that's not the case, what we want to do is we want to make sure that, well, what do you have already? What's the person who is sending it? That's myself. If I'm trying to send a coin, what I have, which is this, it is going to subtract and equal it to the new value, right? The amount. So what this means, this is like saying that, okay, me, this is me now. what I have here, I want to say the amount I have minus the amount, and what I have. Let's say I minus this and I get a value. And let's call that value, right? So whatever value I have, sorry, whatever value I have, I want to say value is going to be my new amount. So whatever is here. So uh, the new balance here is going to be equal to the value. So this is basically what we just did here. We said the balance, what I have initially minus what I'm trying to send, right? Is going to give us a particular amount, after doing the subtraction. And what I have now, the balance now, the new balance. So still in my balance, I want to assign the value, whatever I have, to be this. And there's a shorthand for that. So instead of going through all these processes, you just use this minus equals to amount. So it's going to do the subtraction and put whatever is left to assign it to this particular place here. So we can put our semicolon, right? Remember we have a semicolon here. And when that happens, what happens now? We want to equally say that, well, the receiver, whosoever we are sending this to, right? So, the receiver is going to be, well, we can get the receiver by saying, remember, we are trying to pass the receiver, so we can go ahead and copy this, right? So, the balance is map also with what we have, pass the receiver address and get the balance of the receiver, and with that assign it, add to it. We are just going to, we're just going to add and equals the amount. So plus equals amount, right? And when we do that, what we want to do is nothing else, right? And this works for us. This is actually going to work now. But when we try to do this, right, when we push this, we can try to compile this code right now. We have some error. What is the error? Hmm, expected this or got function. Where is that? Send. Okay. What are we doing? Okay, here we did not. We have to use a semicolon. Let's compile. Now we can go ahead and run this code, right, and push it or deploy it and see what we have. So I can go ahead and open this, and you see we have a mint, right, that is created for us. We have a send coin. And this is red because we have a payable. It means that this can send to, we can send ether to, we can send and receive ether. That's why we have this as red. We have a default getter for balances, and this is because we have balances to be public, right? And we have owner, a default getter for owner, and this is because we have a public for owner. So I can run owner, and you see that this owner is whosoever pushed the code, right? So I can equally run balances and pass the balance of the owner. So let me copy this. You know what? Let's go. Let's copy from here. Copy this. You can see I've copied this. So I just go ahead and specify this. We are going to put it in a string code, right? Because of course the owner is no, sorry, we don't need to put in a string code, do we? No, we don't. Balances, we have zero, right? Because we didn't specify this as a string, so we have zero. Now let's mint some coin. So let me see. For the address, I want to mint for myself, right? Because we specified here that only the owner can mint a coin. Mint, I want to mint, you know, for myself now. For this case, right? I want to mint, let's say 200, right? Let me go ahead and mint, and we successfully did that. Let's get the balance now. See now we have 200 now, right? So let me mint for some other person. Let me go ahead and mint for this account, right? Let me copy this. Let's copy this. Copy. We've copied it. Let's go back to ourselves here. So we are actually minting for this person, right, with our own account. So we place this. Let me mint. Let's mint. Uh, Let's mint 100 for this person, right? And try to mint. We successfully minted for that person. So if I try to get the balance for that person, balance, we've gotten 100. If I try to get for myself, I'm getting 200, right? But if this person now, let's say we make another user, right? So let's call the second user, right? The second user is trying to mint some coin, right? The second user is trying to mint some coin to themselves. It's trying to mint extra 100, right? Let's mint. You're going to see we got an error. And when we look at our error, the transaction has been reverted to the initial state. A reason provided you are not permitted to mint a coin. You can see the reason here, which is you know this only owner here. You are not permitted to mint a coin, right? And yeah, that's basically it. So we can equally send send a coin to some other person. So let me try to send a coin to the first user. So we are currently the second user. Let me copy this. Copy. Now let's go back to who we are, which is this, and let's try to send a coin to the first user. And I want to send 20, right? And send. You can see I successfully sent. So if I try to get my balance again, now this the my that's myself. We now have 20 extra. And if I try to get the person who sent the coin, right? That's the second person now, right? If you copy his own address and go back to the balances and try to get it and call this, we are going to see that his own is now 80. But currently, the what we have is if this happens, right, every time a transaction changes, we'll have to refresh to get the updates. And this is because there is this thing called events, right? We have to, if you want to listen to different events, so when a transaction is sent, you can create an event that listens to that sent transaction so that anytime that changes, you can actually listen to that event and get the state change. So the way you do that is actually use this keyword called event. So go ahead and create an event called send coin event called send coin, and that event is going to accept it's going to have the address. So this is what it's going to publish to us, the address, which is the from, right? And another address which is who we are sending to, right? Which is the the to, and the amount, right? Amount, or which is a uint, right? Of course, int 256, and amount is how much we are sending. Now we've created the event. We have not used it yet, and the way you actually use this event is actually is actually going to publish the event. So you have to be able to emit the event. So you say emit, right? We're emitting the send, and when we emit the send, we're emitting, well, who is sending this? The sender is going to be, in this case, the message dot sender, right? So that is who is calling this function. Remember, it accepts a sender, an address from that's from who is coming from. The receiver is going to be, well, the receiver will pass here, right? Which is the to. So this is coming from this and it's going to this person. And so you can call this basically anything. You can say you can call this sender, you can call this receiver, right? So let's stay consistent. And the amount is going to be, well, whatever amount we try to send. So amount. And with that, we can compile this. We can go ahead and compile this and see if we have any errors. Yes, we do. And what is this? Definitely a semicolon. Definitely. Right. All right, that's crazy. Okay, let's go ahead and compile. I'm so sorry. We are missing lots of semicolons because, well, you know, uh, I'm a JavaScript developer by default, right? So I usually skip lots of the semicolons. So we say that function variable structs or modify declaration. Okay, what is happening? What are we doing wrong? This is so. Okay, yeah, we are calling this outside the function. So please, we need to call this inside the function. Okay, compile. Okay, we still have the same undeclared and identifier. Where is that coming from? Send coin. This is send coin, please. And with that, we have all our problems gone, right? So let's go ahead and redeploy this code. So we'll go to this deployments. For the now, I want to remove this, right? Because this is going to confuse us, right? When we deploy an instance, I will start looking for. But we can deploy an instance and see it, right? So we can see the one we just deployed here, right? If you open it, you're going to see that this is it here, right? And this is the previous one here. So with this events here, you can listen to different events in the real world. So you can subscribe to this event, and when you're using a front-end application, you can listen to that event. And whenever there's a state change, that is, whenever there is a coin sent, you're going to receive the event. Your event is going to notify you that okay, something has happened. You can get that and update your front end application. So with that being said, in the next tutorial, we are actually going to be looking at how we can, go out of this, you know, okay, we are going to look at how we can actually connect our code with a front end application, right? Write some front end, see how things work outside just looking at buttons created for us in the Remix environment. And with that being said, guys, thank you so much for being or participating in this tutorial. Honestly, I'm very, very excited you stayed and followed this course till the very end. This tutorial to the end. The course has not ended yet. The course hasn't ended. But yeah, please, if you like this tutorial, you can hit the like button and subscribe so you can always get notifications from us. Bye.